This video is intended to show dentists the laboratory steps for obtaining screwed structures for the implanted prosthesis with 8 or more elements by CAD CAM technology. The initial step is the scanning. The cast model with teeth will be scanned after proof and approval by the patient. Then, the cast model with transferees in position. Without the transferees, the antagonists and articulated models will be scanned too. After proof, the cast model brings to the software the information of length and width of the teeth, as well as their buccolingual position. The red markings indicates to the software the local for refinement of scanning. After finishing this step, the model is removed from the interior of the scanner. The prosthesis is removed, and on the abutments or implant analogs, special transference for digital capture are screwed. These are made of a material that facilitates scanning with the same geometry as digital transference present in the software. One by one, they are superimposed on the scanned transferees by marking 3 points in the space and organized by 3 axes, X, Y, and Z. Through a specific tool, you can check the accuracy of the fit. The step of positioning on these digital transferees is very important because the operator is providing information about the fit of the final piece. The tools for milling of the end of this video were shadowed with the same manufacturing tolerance of the parts that are made for those abutments or implants, with no craft procedures. The next scanning procedure is still the cast model, but now without the transferees, only the gingival mask. Here, you can better understand the red markings for refinement of the scan. See that the transferees appear at first, but after refinement, it doesn't appear anymore. In sequence, are scanned the antagonist model and byte registration. Is noteworthy that importance of providing laboratories or milling centers the amount of information needed in the form of models or registrations to obtain consistent structures for comfort and strength that our patient needs. At this point, you can analyze the model with digital transferees in position with and without the antagonist and with and without teeth. Completed the scan phase, passes to constructed the virtual structure, the computer-aided design. On the teeth of the scanned model are superimposed the virtual teeth, in green for the pontics and blue for pillars. They are connected in a unique piece, and a command is given to be reduced to the equivalent space for ceramics. The contour of the teeth remains in transparency. So the antagonist is removed, and the model is ordered to stay in an occlusal view. In the axis of each implant, the access holes are marked. In the following steps, in a view without the model, we can see the presence of the implants in the software. When these and the respective abutments are present, they are removed for a final analysis of the proposed work. With the design of the structure ready, is sent to be positioned in a virtual milling blank. This virtual blank is also mounted on a virtual axis, which simulates the milling machine. The machining path is determined. The most economical and fastest way for milling that structure together with several other previously designed. The best places to position the union tunnels and still the refinement of information on the basis of settlement of the structure in the implant or abutment, with its settlement stops of the heads of the screws that hold the prosthesis. While conducting these markings in orange, the information about tools and how they will work in getting those formats. It is associated to the values of manufacturing tolerance required for the original prosthetic components. The designed structure is then forwarded to the CAM system part, the milling unit. The material is then chosen, remembering that these structures can be obtained in zirconia, cobalt chrome, or titanium. The blank is positioned in the milling unit, which has received the file, and then it starts the milling process. In this way, you can obtain complex structures very accurately and without welding and in an overly quick time.